Hi, welcome to Keys Precalculus. This is section 1.1. I'm going over it again with you even though we did do it in class and y'all did some homework because I think you need a little bit more practice with the forms of the equations, especially when it comes to horizontal and vertical lines and also application. At some point in this video, I'm going to give you a verbal assignment. You need to write it down and do it, and that's what you will turn in on Tuesday as homework for this video assignment so you can get credit or points for this video assignment. The first thing we're going to do is review the slope of a line because in this section all we're dealing with is lines. And remember, if you'll recall, the slope of a line is the ratio of the change in y to the change in x. In other words, over a given interval, how fast does the line rise compared to how far does it run in that given interval? Okay, so when you rise, when a line rises or falls, like in this instance, the red line is rising when you read from left to right. The blue line is falling when you read from left to right. But my slope of the line, you pick an interval, is how fast it changes going up or parallel to the y-axis versus how fast does it change going parallel to the x-axis. There's an equation over here that says that the slope is delta y over delta x. Delta is the Greek letter D, and in math it means change. So what is the change in the y values compared to the change in the x values? Change, remember change is difference. So you subtract, that's the operation subtraction. So basically you're saying how far does my y value change divide by how far does my x value change, and that will give you the slope of the line. Now the blue line here, you can consider it falling, which goes negative, and then to the right, which is positive, and negative divided by positive is negative. Or you can say rise, which is positive, and then go left, whoops, I'm not doing a very good job, which is positive, and negative by positive is a negative. So when you're reading from left to right, a line falls if it's got a negative slope, and you can see that it goes left to right, or it rises if it's got a positive slope. You're either rising positive, running positive, or you are falling negative, and then running left, negative, and negative divided by negative is positive. So what am I talking about? Well, let's do an example. Let's say we're given the points -3, -2, and 1, 6. And I'm asking you to find the slope of the line that goes between those 2 points. Well, what you would do is you would use this formula, the change in y, or the second y minus the first y, divided by the change in x, or the second x minus the first x. Now, it really doesn't matter if I go second to first. I could go first to second, as long as I did the first y minus the second y over the first x minus the second x. But let's go ahead and just do it the order that they have it in. So if I said find the slope of the line between these 2 points, and I don't have graph paper to figure it out or to count it, or these numbers are really big and I don't want to plot them out, I can do it algebraically just by saying taking my second y, which is 6, and subtracting my second x, or excuse me, subtracting my first y, which is -2. Now, I have to have a minus here, and then I put my -2. This minus right here is not the negative here. This minus is part of this equation right here. So it's minus whatever that value is. It will end up canceling each other out and becoming positive, but I don't do that initially. Then I take my second x, which is 1, and I'm going to subtract the value of my first x. So this is really saying 6 plus 2, because minus and negative becomes positive, and 1 plus 3. Now, obviously some of you can do this in your head, and that's really okay if you think it in your head and you just want to write out this second form of the equation right here. That's fine. But if you think you're going to make mistakes with negatives, go ahead and write everything out first. And then 6 plus 2, or you can skip, I should say, you could also just write this out and then skip straight to the answer, which would be 6 plus 2 is 8, 1 plus 3 is 4, and then 8 divided by 4 simplified is 2 over 1, or you can just write it 2. And that gives me my slope. So that is the slope of a line that passes through the point -3, -2, and 1, 6. And if we're talking about just a regular line, it's going to have the same slope no matter where it is on that line. Or I should say it's going to have the same slope no matter what points I choose on that line. Now, why would I care about this? Well, we need to know the slope of a line in order to find the equation that represents every point on that line. If you know the slope of a line and you know a single point on that line, you can write a general equation that will give you every single point on that line. The equation is general enough that you can plug in any x and it'll pop out a y, and that coordinate will be, or that set of ordered pairs will be on your line. Every line has an equation associated to it. The general form of your equation is this red equation down here, where it's a times x plus b times y plus c equals 0. A is a coefficient of x, b is a coefficient of y, c is a constant, and it equals 0. A and b are not both 0. You're going to have either an x value or a y value. If they were both 0, then you would have the constant equal 0, and that's not true, because unless the constant is 0, you wouldn't have anything. You'd have in order to have the general form of an equation, you have to have either an a value that's not 0 or a b value that's not 0, or both. Well, obviously both don't have to be 0. And then the standard is that a and b are both integers if you want it to be fully standard. But really it's basically the general form of an equation of a line is your your x and your y and your constant are on one side, and the whole thing equals 0. Okay? But that's not generally how we look at lines. We look at lines we figure out lines by one of these other forms, either the point slope form or the slope intercept. Slope intercept is the easiest to read and to graph, but there's not always the easiest, it is not the easiest to figure out the equation of a line from that. In order to figure out the equation of a line, you really need point slope form, because in point slope form, all you have to have is one point and the slope, and you can figure out the equation of a line, which we're going to do with this, these 2 points that we've already worked with here. If I said write the equation of the line between the points -3, -2, and 1, 6, you could do that. The first thing you have to do is find the slope, which we already did. The second thing is you've got to write an equation for it. Your equation needs to have a y and an x, one or the other, or both. And in this case, it's going to be both, because my slope is 2, so I'm going to have an x and a y. So what I'm going to do is I'm going to take this point slope form of the equation, the purple one, and I'm going to write my y, which is any y. It's general, so I have to have it there, minus y1. Now, this y1 is going to either be from the point -3, -2, or from the point 1, 6. It doesn't matter which point I choose. I just have to pick one of them. So I'm going to pick this point right here. I cleaned it up, although I know that there's some gray showing up here. I don't know how to make that go away. But anyway, I'm going to pick the second order pair simply because the second order pair has positive numbers, and positive numbers are easier to deal with. So I'm going to say y minus, and I'm going to pick this second y, which is 6. Because I picked that order pair, I have to use that x2. Equals m, which I figured out my slope was 2, times, I'm going to have my x here, which is the same x as over here, minus my x value, which is 1. And again, I am so sorry. I do not know why those gray boxes are there. They just keep showing up every time I move my pen. All right, so that's the point slope form of an equation, and this is fine. Okay, this is an equation of a line, and it works. But if I say put it in slope intercept form, in other words, solve for y, you could do that too just by manipulating the formula, or the equation. So I'm going to do that by doing some basic algebra. First thing I'm going to do is I'm going to distribute the 2 on the right side. So 2 times x is 2x, and 2 times -1 is -2. I've distributed this 2 to everything in the parentheses, because that's what it means. Now I'm going to add 6 to both sides, and when I do that, I get y equals 2x plus positive 6 plus negative 2 is a positive 4. So 2x plus 4. So this green equation is the slope-intercept form of the same line that passes through the point negative 3, negative 2, and 1, 6. I could have done the same thing with the point negative 3, negative 2 in the purple and then down to the green, and it would have been, the green would have ended up being exactly the same thing. If I want to put it in the general form of the equation, then I would move my 2 to the other side. Hang on just a second. I'm going to change my pen color here. But anyway, that's what I was doing. So anyway, I'm going to move my x to the left side and my 4 to the left side. Or I could just move my y to the right side is what I could do, which would make it easier. That way I'm not dealing with a leading value of that's negative. So if I subtract y from both sides, then I get 0 equals 2x minus 1y, which I don't need to show the y, plus 4. And it doesn't matter if the 0 is on the left or the right. This is the general form of the equation of a line. And these are all three, the purple, the red, and the green are all three equations of the same line. They're just in different forms. Go ahead and pause the video and just think about this for a couple minutes. Just study it, think about it, make sure you understand it. Now let's not forget that parallel lines, lines that in the same plane do not intersect, have the same slope. And perpendicular lines, which I said they intersect at right angles in a plane, but they intersect at right angles no matter what, whether they're in the same plane or not, but they would be in the same plane if there's only two of them. They have negative reciprocal slopes. We went over this in class quickly, but you can visualize it, you can draw it, you can visualize it. We're going to work a problem using parallel and perpendicular. So here's the problem. This is the equation we figured out, y equals 2x plus 4. That was to the original problem we did. That's the equation of that line in the slope-intercept form. But if I say, write an equation of a line that passes through the point 2, 1 and is parallel to the line y equals 2x plus 4, can you do it? Well, yes, you can. Because what do you need to write the equation of a line? You need a point and you need the slope. And if I say to write an equation of a line passing through the point 2, 1 that is parallel to this green line here, all you have to do from this green line is take the slope off of it. So my slope in this green line, oh, I'm so sorry, didn't mean to shift that around, but is, in this case, it's this right here, it's 2. We figured that out already when we figured out the slope between 2 points. But this is the equation of the line, this is the slope of it, m equals 2. If it was not in this form, if it was in this general form, ax plus by plus c equals 0, I would have to put it into this form first to find out my slope. You've got to take a general form and you've got to convert it to the y equals the slope-intercept form, but all you do to do that is to solve for y. You just want to get y on a side by itself with a coefficient of 1. And when you do that, that's when you find your slope. Okay? And so now that I have that, I have the slope and I have this point 2, 1. So now I can write the form of an equation, and but I can't use slope-intercept. I'm going to have to use point slope. But I can write an equation with this information. And I do that using the point slope form of the equation. So I'm going to take my y minus, now I don't have a y1 or x1 to choose from. I only have one point, which is the point 2, 1. The y value is 1. So y minus 1 equals my slope, which is here, 2 times x minus the x value, which is 2. I can leave it like that, but if I tell you to put it in slope-intercept, a general form, you can do that as well. To put it in slope-intercept, you simply solve for y. So I get y minus 1 equals 2x minus 4. I add 1 to both sides, and I get y equals 2x minus 3. That is not the same equation as this one, but it is the equation of a line that is parallel to that one because they have the same slope. I can leave it in this form. If I tell you to put it in the general form, then you just put everything on one side and make it equal to 0. That's if I gave you the instructions to write the equation of a line that is parallel to the green one. But what if I said, write the equation of a line that is perpendicular to the green line and passes through the point 2, 1. Once again, I would need this point and the slope. Now, I know that the slope of this green line is 2. But if I wanted to draw, or if I wanted to find the slope of a line that is perpendicular to this line, its perpendicular slope would be the negative reciprocal of 2. Negative meaning the opposite sign. So if it's negative, it would become positive. If it's positive, it would become negative. In this case, it's positive, so it's going to be negative. And then I would write the inverse, or the reciprocal, the multiplicative inverse. So 2 over 1, because 2 written as a fraction is 2 over 1, becomes 1/2. So the slope of my perpendicular line, and that's what this symbol right here means, it's an upside down T. Slope of the perpendicular line is negative 1/2. So I could do this all over again, but instead of writing a 2, I would write a negative 1/2. So y, oops, I didn't mean to put both of those. Y minus 1, because that's my y value, equals negative 1/2, and then x minus 2. And then I would distribute, and I would get y minus 1 equals negative 1/2 x. Negative 1/2 times negative 2 is positive 1. And then I add 1 to both sides, and I get y equals negative 1/2 x plus 2. So there is the equation of a line that is perpendicular to this green line here and passes through the point 2, 1. Take a minute, pause it if you need to, study it, see what to do. Now we need to talk about horizontal and vertical lines. Okay, the slope of a horizontal line, as you can see this pink line I drew up here, is 0. That means there is no rise. You're doing nothing but running. There's no rise, so my y value, my y1 minus y2 would always be 0. It doesn't matter what x2 minus x1 is, because 0 divided by anything is 0. So the slope of a horizontal line is always going to be 0. And the equation of a horizontal line is going to be simply y equals wherever it crosses the x-axis, that b, not the x-axis, the y-axis. Wherever this line crosses the y-axis, that's the y-intercept, in this case, it's a 2. But the general case over here is y equals b. But the specific case in the line I just drew, it crosses the y-axis at 2, so the equation of my horizontal line is going to be y equals 2. Horizontal lines are always going to have just a y variable equals some constant, because it doesn't matter what point I put on this line. I could have x is 2, y would be 2. X is 0, y is 2. X is negative 1, y is 2. Every point on this pink line, my y value is going to be 2, so that's the equation of the line, y equals 2. The x value, because the slope, and think about it this way, because the slope is 0, it makes this x over here go away, because 0 times x is 0, and you don't have to show it. So a horizontal line is always going to have the equation y equals some constant. Now the vertical line is the perpendicular of a horizontal line. And remember, perpendicular lines have negative reciprocal slopes. So if the slope of my horizontal line is m equals 0, that's like 0 over any number, 0 over 1, 0 over whatever number it is. But if I were to take the reciprocal of that and flip it, or the negative reciprocal, negative 0, well, negative times 0 is going to, there's not a positive or negative 0, 0 is just 0. But if I were to take the negative, that negative, and then I would have the negative of whatever this was over 0. Well, what's wrong with that? You can never have 0 on the denominator. It's undefined. So a vertical line has an undefined slope. Also, you can think of it this way. I'm rising however far I rise. It doesn't matter, but when I run 0, I'm going to have a 0 on the denominator. Therefore, my slope for a vertical line is undefined. Now, a vertical line, like I said, is perpendicular to a horizontal line. A vertical line, unless it's on the y-axis, does not cross the y-axis. It only crosses the x-axis. So there is no y-intercept. There is no way to write an equation in the form y equals mx plus b. You have to write the equation in the form of just an x, because on this orange line here, it doesn't matter what my y is, my x value is going to be the same. In this case, it's a -3. So every x on this line is a -3. -3, 0, -3, 1, -3, 2, -3, -1, -3, -2. It's all -3 is my x, but generally x is equal to, they say a in your book. So it's just x equals some constant will give you the equation of a vertical line. A vertical line will have no y value in it. It will just be x equals some constant, and in this case, x equals -3. So let's do an example with this. Let's say I give you the point 3, -2 here, and I say write an equation of a line through the point 3, -2 that is parallel to this pink line up here, the y equals 2, and it is perpendicular to the pink line, y equals 2. Can you do that? Well, yes, I can. First of all, my point 3, -2 is down here. So I need it to go through this point and be parallel to the pink line and then also perpendicular to the pink line. Now, I see that my pink line, in this case, the slope is 0, right? So, and I know it's a horizontal line. So yes, my slope is 0, but I also know it's horizontal, so it's y equals 2. The equation that is parallel to that line is going to be also a horizontal line. So it's going to be y equals some number. Now, I can't just pull some number out of the air. It has to be through this point 3, -2. Where is this point going to cross the y-axis? Well, if it's horizontal, it's going to cross, oh, I went too far with that. Let me move my point here. Hang on just a second. I am so sorry. I plotted the point 2, -3, not 3, -2, but I fixed it. So here it is, 3, -2. So it's got to go through this line, or this point 3, -2. It has to be perpendicular, not perpendicular, parallel to my pink line. So it's going to be another horizontal line that goes through that point. Now, where's that point going to pass the y-axis? It's going to be at -2 because every y value on this line is -2. So it's y equals -2. So the equation of a line that is parallel to the pink line and passes through the point -3, 2 is y equals -2. The equation of a line that's perpendicular to the pink line and passes through the point 3, -2 is going to have an undefined slope, but I also know that my perpendicular lines are always going to be of the form x equals some constant. And what's that constant? Well, the constant is going to be where it crosses the x-axis, and in this case, if the line were to continue going up, it would cross the x-axis at that x point, x equals 3. I can't just make it up randomly. I have got to use the point I was given. Okay, so the point I was given was 3, -2. A line parallel to any horizontal line through this point would be at y equals -2, and a line perpendicular to any horizontal line at this point would be a vertical line, and vertical lines are always going to be in the form of x equals some number, and in this case it's 3 because it has to pass through that point. Does that make sense? I think every single one of you missed that on the quiz. You can't just make up a point. You have got to use the point you were given. Okay? So now I'm going to give you some problems to practice. So write this down. I want you to do page 11, numbers 8 and 14, and page 12, numbers 34, 36, and 38. I'm going to add some problems to this, but for now, this is what you need to practice on. If you want to pause and do the problems now, you can while this is fresh, or you can finish watching the video and then finish doing the problems. Right now, we're going to go through an application problem. Step by step, together just so you can practice using this, taking what you've learned and applying it to real life problems. Okay, so we're going to look at number 68 on page 13. It says earnings per share. The graph shows the earnings per share of stock for Harley-Davidson, Incorporated for the years 1992 through 2002. This is actual data that they use. We're going to skip A because I don't want to find the slopes of everything. We're going to look to B. It says find the equation of the line between the years 1992 and 2002. So basically in 1992, which is they use the point 2. You can use the point 2 for your x, or you can use 1992. The idea is if you use 1992, you're going to end up with the same answers as if you use 2. However, they're going to be much bigger numbers. I mean, same equation, but you're going to have to deal with much bigger numbers. So it's a whole lot easier to use 2 than 1992. But what we're going to do is in 1992, the stock earnings were 0.19. Okay? 19 cents, I guess, per stock. Now, or that's what they earned. In 2002, which is associated with the number 12. Okay, so 2002, because even though it is 2002, sorry, even though it is 10 years more than 1992, it is 10 more than 2 is 12. So that's why they use the number 12. The stock earnings in 2002 were $1.90 per share. So they went up greatly. The problem says find the equation of a line between these 2 points. Okay, this works the same way you've been doing all the other problems before. I could use 1992 and 2002 instead of 2 and 12, and I would get the same slope. I would get the same equation of the line. But in this case, because it makes it easier to use smaller numbers, let's just use the smaller numbers. Okay, so first I would take my y minus, or my y2 minus y1, or my y1 minus y2. It doesn't matter, but because my y2 is bigger, I'm going to say 1.9 minus 0.19. And then I'm going to put it over 12 minus 2. Well, obviously my denominator is 10. My numerator is going to be 1.9 minus 0.19, or 1 and 9/10 minus 1900ths, which gives me 1.71. And when I divide that number by 10, dividing means I move my decimal place left 1. So I get the number 0.171. So my slope is either 1 71/100ths over 10 or 171 thousandths. Okay? Over 1. That would be my slope, or the rise of my stock value per share from in 10 years. That's my slope. I'm going to use this slope here to write an equation that represents the line that goes between these 2 points. I can choose either point I want. I'm going to choose the first one because it's got smaller numbers. So y minus 0.19 equals, not x, sorry, equals my slope, which is 0.171 times x minus 2. And then I can distribute 0.19, and I get 0.171x minus 0.342, because I doubled 0.171. And then I'm going to add 1900ths to both sides. So I get y equals 0.171x minus, because 0.342 is bigger than 0.19. So I'm actually going to subtract them. And I get negative 0.152. So that's the equation of the line that shows the growth in stock value between 1992 and 2002. That's part B. Part C says use this to evaluate if it was stayed constant, if it stayed the same. Use it to evaluate what your stocks would be worth in 2006. So from 2002 to 2006 or 2012 to 2006, it doesn't matter which point you use. I mean, actually, you don't need to use a point. You've already got the equation. You just need to figure out what your X value is. X value is the year, and your Y value is going to be how much you earned. Now, X value, when I say you need to figure out the X value, you can figure that out just by subtracting. Your Y value is what you're going to find by subtracting or plugging that X value into the equation. So between, if 1992 was the number 2 and 2002 was the number 12, the year 2006 would be equivalent to the number 16. So in place of X, I'm going to put a 16. Now, if you did it with 2002, 2012, 2016, you could do those numbers too if you had started that way, but those are just bigger numbers to deal with. So in this case, I can just put a 16 in this place, and so I'm going to get Y equals 0.171 times 16, because that's my year 16. Everything on this line, every X on this line is going to have a Y value associated with the slope at minus 0.152. I'm sorry, I'm rambling. Basically, I'm going to take this 16 right here, and I'm going to plug it into this X to get this equation up here so I can solve for Y and figure out how much my stock value would be if it was to continue rising at the same rate. So when I simplify this, I'm going to get Y equals 0.171 times 16 gives me 2.736, and then I'm going to subtract my 0.152, and then I'm just going to go ahead and subtract those numbers, and when I get that, I get 2.584. So that's how many points this stock value will be in 2006 if it continues to rise at that same rate. Now the question they asked on part D, I'm sorry, I put part C, but I meant to put part D. I was not going to interpret that, but I guess we could interpret it. Let's go ahead and interpret it. It says interpret the meaning of the slope of the equation from part B, which is the one I put in a box, in the context of the problem. So basically all that means is that the average increase per year from 1992 to 2012, excuse me, to 2002 is 0.171. Okay? That's the average. It's not a real life, or excuse me, part D asks if this is, do you think that this is an accurate estimation? Well, it's not accurate. Part D says if it was to continue on that average, then that year the stock value would be $2.58, $2.58.4 per share. That's not actually accurate. It is a linear model if it were to continue linearly, but in reality, stocks, just like you can see in the picture, go up and down. Sometimes they go up at a steady rate, but they may rise faster one year, may rise slower another year. They may fall. Okay, so it's just a linear interpretation of what it could be if the average stayed the same. I am so sorry those little things showed up at the bottom. I guess I was hitting something I shouldn't have hit. Like I said, this is not my forte. But anyway, I'm going to add a couple problems to your assignment. I want you to add page 14, numbers 71 and 73. They're similar to the problems we were just doing. This number 68 we just did and number 67 you did for homework. But they're you're going to have to make your own interpretation from that. It's a little bit different, but it's very, very similar to what we just did. Practice these problems, bring them in, check them, bring them in on Tuesday, and I will have the answers written out for you. Y'all have a great weekend.